All right, guys, a little bit more with graphing quadratic equations. So we've done a lot with actually looking at the graph of a quadratic equation, but what if you are given the formula? Would you be able to pull out different pieces in order to graph that quadratic equation? Okay, so a couple of important things that you want to remember is this formula right here is huge. X equals negative b over 2a. When you use that formula, that gives you your axis of symmetry. Now, think about your quadratic equation. If you know your axis of symmetry, you know the points, the x value that's going to split your parabola down the middle. Okay, so that means that you could find your vertex. And then if you found one point on this side, since you know your axis of symmetry, you could find a second point very easily without even doing any math. You could really just, count it out. If you found a point over here, same thing. You could just use your axis of symmetry to plot another point, and then you could create your curve. Okay, so this x equals b or negative b over 2a is very, very important because that's kind of like it's a starting point for when you're coming up with your values of what you are going to graph when we're trying to graph a quadratic. All right, so first thing we're going to do is we're going to find the axis of symmetry. Then when you find your axis of symmetry, that's giving you not only the axis of symmetry, but the x value of your vertex. So if you take that and you plug it into your equation, you're going to get the y value of your vertex. So right there, once you found your x and your y of your vertex, there's a point that you can graph. Okay? Since you know that's your vertex, you're going to pick a couple of x values to the right and to the left of your vertex, plug them into your equation, and get some corresponding y values. All right, after you have a few points, you can connect your points and you will have a graph of a nice curve going up or down, skinny or compressed, however the equation is given to you will determine what your graph looks like. Okay, so let's look at an example. So example number 1, we have this equation right here where it says f of x equals x squared plus 6x plus 1. Okay, so first thing, when I look at this, I start to remember the things that we have talked about already, okay? Because I just want to be able to double check myself. I noticed that my a value, the coefficient of the x squared term, is 1. It's positive. So right there, I think, okay, after I'm done graphing, I know I'm going to have a curve that goes up like this, okay? I also look at this and I think, okay, well, I remember that my C value is my y-intercept. So I want to make sure that my graph is going through where y equals c. Okay. All right, so now I'm going to work through this a little bit. I look at my equation. I know my a value is 1. I know my b value is 6. And I know my c value is 1. Like I had already said, I know my parabola is going to open up. Since it's opening up, I know that vertex is going to be down here. So it's going to be a minimum point. And like I already said, I know that my y-intercept is going to be positive 1. Okay, so the next thing I'm going to do is I'm going to find that axis of symmetry. So I'm going to do negative 6 over 2 times 1 And that gives me -3. X equals -3. So I know that when x equals -3, this right here is what's going to be my axis of symmetry. So after I get a couple points in my curve, that line should just cut it right through the middle. All right, so I know my axis of symmetry. This is also very important because that's going to be the x value of my vertex. Okay, so if I know my equation is f of x equals x squared plus 6x plus 1, what I'm going to do is if I know that my x is -3, oops, I know if my x value is -3, I got to figure out the corresponding y value that would go with it. So I am going to plug in -3 in for x into my equation. All right, so when f of -3 if x is -3, my y is going to be -8. So what does that mean? That means that my vertex, my x, is -3. My y value is -8. Now remember, the vertex is the turning point, or is like the center of this quadratic, this particular quadratic. So I am going to put -3, -8 in the middle of my chart. All right, then I can put in my calculator that equation. Okay, so in my calculator, I put x squared plus 6x plus 1. If you hit second table, this is going to give you your table of values. Now, since I know that -3, -8 is my vertex, and that's my turning point, I know that I'm going to do a couple of values above, or below, I should say, -3, and a couple of values above -3. And I can fill those into my table. So I can do -2, going in the opposite direction. But it doesn't matter what direction you go in, though. I can do -4, -5, -6, -2, -1, and 0. All right, so when x is 0, I get 1, I get -4, I get -7, I get -8, I get -7, I get -4, and I get a +1, not -1. All right, so now I'm going to plot those points. So I have -3, -8, and that's my vertex. I have -2, -7. I also have -4, -7, and it's symmetrical, so it's easier to kind of go back and forth plotting your symmetrical points. -3. I already did that one. -4, -7. Just did that. -5, -4. Right there. -4, -7. This is very difficult for me to see. -6, +1, And then I'm going to go in the opposite direction. 2 and 3. And I can draw my curve going, oh, that's terrible. I can draw my curve going up the best that I can, connecting those points. And this is the equation f of x equals x squared plus 6x plus 1. Okay. Now, a couple of the questions that it's asking me is what is the domain? Remember, the domain is all of your x values that are being covered. So since this goes off into positive infinity, it's going to keep going out, 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 and it goes up into positive infinity for the y's. It's going to keep going out, 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 out. Your domain is going to be negative infinity to positive infinity. Now the range is going to be a little bit different. The range is talking about the y values. Now the range, it only goes as low as -8. It does include -8, so I'm going to do a bracket, -8, but then it does continue to go up, 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 up forever. So it will go from -8 until infinity. Okay, then it says identify the roots. Now, if you look at your graph, it's very difficult to see where the roots have crossed the x-axis. Okay, so what you can do is you can go into your graph, and I think I showed you this yesterday. If you hit second, trace or calculate, go down to 0, because remember, roots are the same thing as finding the zeros. So I'm going to scroll over until I am to the left of where this graph and the x-axis intersect. I'm going to hit enter, and then I'm going to scroll to the right of where the graph and the x-axis intersect, and then hit enter again, and I get -5.28427. Okay, that's rounding. You got to remember that this is rounding the answer, which is fine for right now because the directions aren't giving us whether to round or write it in simplest radical form. Or if it says to write it as an exact answer, that means you got to write it in simplest radical form. Anytime you're writing it as a decimal, you're rounding it. 6.828427. And notice how I am writing the whole entire decimal out. That's what you're required to do this year. All right. Let's see what the other root is. Okay, so second trace, go to 0. And now I'm going to scroll over until I'm just to the left of where the curve is going to cross the x-axis here. Then I'm going to scroll over to just to where it's to the right of where it's going to cross. Hit enter, enter again, and I get -0.1715. So my other root is -0.1715729. Again, that's an approximation. It's not exact. If it said to write exact, we would do it in simplest radical form. Okay, then it says, over what interval is this increasing? This goes back to the beginning of the year again. Okay, beginning of the year, we talked about increasing and decreasing. Okay, so when I look at my graph from here to here, it's coming down, 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 down. That means that it's decreasing. So the interval for decreasing is going from negative infinity until it gets to this point. And remember, this point right here is negative 3. Okay, so it's decreasing from negative infinity to negative 3. But then all of a sudden at that point, and then it goes back up. So now it starts to increase again. So the interval that it increases at goes from, I feel like I gotta get another color, negative 3 to positive infinity. Okay? And then the rest of these are very similar. It's just the same thing, pulling out the y-intercept and the vertex and the min and the max. If you have any other questions, feel free to email me and I can go over any of these other problems with you.